Good morning, class. Okay. Let us all stand and pray. Prayer leader, please lead the prayer. Amen. Okay, before we start, I would like you all to please pick up the pieces of papers under your chairs and have your chairs properly aligned. Alright, go. Okay, you may now take your seats. Let me check your attendance first for today. Is there anybody absent here in the class today? No one? Okay, very good. It's nice to see that all of you are present here today. Now, let us first have a short recap on what we have discussed last meeting. Who would like to share what we have discussed last meeting? Yes, miss. Very good. Last meeting, we have discussed sequences. And who can define what sequences are? Yes. Precisely. A sequence is a function whose domain is in the finite or infinite set. Okay. Now, who can differentiate infinite sequence from finite sequence? Anyone? Yes. Yes, that's right. Amazing. Finite sequence do have ending elements, while infinite sequence do not have. It is endless. Alright, is there any questions regarding our topic discussed last meeting? No one? None? Okay, and because of that, I believe you are ready to learn more. Am I right? Okay, let's start. Okay, before we start our discussion, I will have to group you. I would like to group you into 3 groups. And we will have this activity entitled, What Do We Have in Common? Okay, this activity goes like this. Below are squares formed by popsicle sticks. Do you see this picture at the back? Can you see? Okay, very good. As you can see, there are 5 sets of squares, right? And you are going to count the number of popsicle sticks in each figure and record the results below. So here is a table. This is where you are going to tally or record your observation. Okay. Is this clear? Is this activity clear? Are there any questions? Okay. You have 15 minutes to finish this activity. Alright, go. You may now start. Okay, are you done? Time is up. Are you done? Everybody, are you done? Okay, let us now start our presentation. Okay, I would like to ask a reporter or a representative from each group who will present and share their observation in front of the class. Alright, let's start from group 1. The floor is yours, group 1. Alright, very good presentation, group 1. How about the group 2? Over here. Excellent presentation as well. How about the group 3? Okay. You may now start group 3. Alright, very good presentations. Okay. Okay, based on your presentations, all of the groups have come up with a very similar observation. Am I right? And this observation is like this. It is presented in this table, right? Okay. Since all of you have come up with this presentation, with this similar observation rather, I would like to ask, how would you describe the number of popsicle sticks there a pattern? Anybody from any group who would like to answer? How would you describe the number of popsicle sticks? Is there a pattern? Okay. Alright, there is. And if there is, how is each number found? How is each number of popsicle sticks was found? Anyone? Anybody? Yes. Very good. We can obtain the next term or the next number of popsicle sticks by adding 3 to the preceding number. For example here, we can observe in the first set of a square, we only have one square, right? And in that one square, we utilized 4 popsicle sticks. Am I right? Alright. And in order to find the next terms, we must add 3 to the preceding terms. So 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. And 13 plus 3 is 16. Alright. Is this clear? Okay. Given this condition, the series of numbers represented by the number of popsicle sticks 4, 7, 10, 13, and 16 is a sequence. And what kind of sequence is this? Okay, yes. Yes, that's right. The number of popsicle sticks 4, 7, 10, 13, and 16 represents an arithmetic sequence. And thus, for today's lesson, we are going to dig deeper about arithmetic sequence. Alright. For now, I want to present to you our lesson objectives for today. Let us all read. Okay. At the end of the lesson, the students would be able to, number 1, defines arithmetic sequence. Number 2, supply the missing terms of an arithmetic sequence, and the third and the last one is observe the value of accuracy. Okay, for now, I want you all to examine this given set of numbers. Okay, what are the numbers? 1, 3, 5, 7, and 9. Okay. Given this set of numbers, do you think it is an arithmetic sequence? Anyone? Yes. Yes, it is. And why do you think so? Yes, it is an arithmetic sequence because we add 2 from the preceding term to obtain the next number, right? So, that's right. An arithmetic sequence is a sequence in which term after the first is formed by adding a constant number to the preceding term. Okay, again, let us all read. An arithmetic sequence is a sequence in which term after the first is formed by adding a constant to the preceding term. Okay, an arithmetic sequence is a sequence where every term after the first term is obtained by adding a constant called the common difference. Take note of this. By adding a constant called common difference denoted by D. Again, let's go back to our given set of numbers. 1, 3, 5, 7, and 9. Again, when we say common difference, it is the constant added to the preceding term to obtain the next term, right? Is that clear? Okay, am I getting across, class? Okay, in this given set of numbers, we have 1, 3, 5, 7, and 9. You said earlier that this is an example of an arithmetic sequence. If this is, what is the common difference? Again, what is common difference? It is the constant added to the preceding term to obtain the next term. So in this given set of numbers in this arithmetic sequence, what is the common difference? Anyone? Yes. Yes, very good. The common difference is 2. To further elaborate, we have the constant number or fixed number is called the common difference denoted by D. Again, yes, the constant number or fixed number is called the common difference, and it is denoted by small letter D. And we have here the formula of finding the common difference. We have D is equal to A sub n minus A sub n minus 1. Okay. Is this clear? Okay, very good. Okay, furthermore, each number in the sequence is called a term. So any number in any sequence, not only arithmetic sequence, any number or each element is called a term. Okay, term or terms depending on how many numbers or elements there are. Okay. Again, let's go back to our given set of numbers, given arithmetic sequence. We have 1, 3, 5, 7, and 9. What is the first term, the second term, and so on and so forth? Who would like to try? Yes. Let's start with the first term. What is the first term? Yes. Yes, very good. The first term is 1. And first term is denoted by A sub 1. Okay. How about the second term? Yes. The second term is 3. And it is denoted by A sub 2. Okay. Second term is denoted by A sub 2. How about the third term? Yes, 5 is the third term, and third term is denoted by A sub 3. How about the fourth term? Yes, the fourth term is 7, and it is denoted by A sub 4. How about the fifth term? Yes, the fifth term is 9, and it is denoted by A sub 5. Is this clear? Do you already know how to find the first, second, and third term, and so on and so forth? Okay, very good. Let's move forward. Okay, we can see in this given set of numbers, there are only 5 terms. What are those? 1, 3, 5, 7, and 9. There are only 5, right? Okay, suppose we are to find the 20th, the 50th, or even the 103rd term of the sequence. How are we going to do that? How are we going to find them? Do you think a formula would help? Yes, very good. We definitely should find a formula in order to find any term of an arithmetic sequence. But what is the formula in finding the nth term of an arithmetic sequence? If the first term and the common difference are given, it is easy to find any term in any arithmetic sequence by using this rule. A sub n is equal to A sub 1 plus the quantity of n minus 1 multiplied by d, where A sub n is the nth term, A sub 1 is the first term, n is the number of terms, and d is the common difference. Okay, please take note of this formula, because we are going to use this all over and over again. So, class, you should familiarize yourself with this one. Okay, is this clear? Okay, very good. Now again, let's go back to our given set of numbers. We have 1, 3, 5, 7, and 9. We only have 5 terms, right? What if we are going to find the 10th term? What is the 10th term? Okay, who would like to try? Anyone from the class? Yes. Very good. Okay, that's very good. The 10th term is, again, 19. So, let's further elaborate how Miss did do that. Okay, since a sub 1 or the first term is 1 and t is 2, common difference is 2, right? We have already obtained it earlier. Alright, since the first term and the common difference are given, we can now use the formula to find the nth term. Again, the formula is a sub n is equal to a sub 1 plus the quantity of n minus 1 multiplied by t. What is n? N is 10. Very good. N is 10 because we are to find the 10th term of this sequence, right? Okay. N is 10, so a sub 10 and a sub 1 of the first term is 1 and the common difference is 2. We can now substitute the following values to our formula. Am I getting across? Okay, very good. So, by substitution, we have 1 plus the quantity of 10 minus 1 multiplied by 2. Again, 10 minus 1 is 9, multiplied by 2 is 18, plus 1 is 19. Thus, the 10th term of this sequence is 19. Okay. Do you have any other questions? Do you have? Please raise your hand if you have questions. Is the topic clear, class? Don't hesitate to ask questions, guys. It is okay. I would love to answer your questions. Okay. Are there questions? Okay, none so far? Okay. Because you said you have no questions, let us have a short application. Alright? Because you said you have no questions. I think you already know the lesson. You mastered the lesson because you have no questions. Am I right? Okay. Let us first have an application, a short application. So, please answer this given problem on your notebooks. On your notebooks only. And I will ask somebody to share and explain your answer here in the front of the class. So, what is the problem? Suppose you jog every day to maintain good health. On the first day of the week, you run 150 meters. On the second day, 155 meters. And on the third day, 160 meters. And on the fourth day, 165 meters. How many meters should you cover on the 8th day? Okay, do you understand the problem? Okay, very good. I will give you 5 minutes to answer this problem on your notebooks. And I will call somebody again to present his or her answer in front. Okay, your timer starts now. Okay, time is up. Are you done? Okay, very good. I want Miss to please share your answer here in the front. Okay? Okay. The floor is yours. Yes. Come on, come over here. Okay, very good. Let's give her a hand of applause. Again, how many meters should you cover on the 8th day? It is 185 meters. Again, I will further elaborate her solution. Okay. According to Miss, we should find first the common difference. Is that right? Yes. Before we get the nth term, we should find first the common difference if it is not given. But if it is given, it is already given, we can proceed to the solution. To the formula rather. So, the common difference is 5. Very good. Now, we already know the common difference. And the first term, right? We know that the first term is 150. Okay. So, we can now use the formula and substitute the values. N is 8 because Okay, we are going to find the 8th term, or the distance covered on the 8th day of jogging, right? So n is 8. So we just need to substitute the values and proceed to simplifying the equation. So 8 minus 1 is 7, multiplied by 5 is 35, plus 150 is 185 meters. Thus, you should cover 185 meters on your 8th day of jogging. Okay, is this clear? Are there any questions? And by the way, who got the same answer? Wow! All of you got the same answer. Wow! Very good. Excellent work, class. Okay, and I believe you already know this one. Okay, so for now, let us have an evaluation. Alright, please get one whole sheet of pad paper and answer this one. Give the common difference and supply the missing terms in each arithmetic sequence. So, you need to find the common difference of each arithmetic sequence, and you need to find the missing terms of each sequence. Is this clear? Are there questions regarding our evaluation for today? None? Okay, I will give you 10 minutes. Is 10 minutes enough? Okay, I will give you 10 minutes to answer this evaluation. Okay, your timer starts now. Okay, time is up. Are you done? Everybody, are you done? Okay, since all of you are done, please exchange your papers with your seatmates and let us check your answers. Okay, give the common difference and supply the missing terms in each arithmetic sequence. The first one, the missing terms are, who would like to try? Yes, 11 and 14, and the common difference is 3. Very good. How about the second one? Yes, the common difference is 5, and the missing terms are -3 and 2. Very good. How about the third one? Yes. Yes, the missing terms are -11 and -5, and the common difference is 6. Okay, how about the next, the fourth one? Who would like to try? Yes. Yes, the common difference is 1, and the missing terms are 9 and 10. How about the last? Yes, the common difference is -4, and the missing terms are 4 and -2. Okay. Okay, are you done checking your papers? Okay, who got perfect? Wow! Majority of the class got the perfect score in this activity. Wow, that's very good. Let's clap our hands. Okay, please pass your papers to the front and I will collect it later. Okay, before I end our lesson, I would like to give you an assignment to further enhance your skills in arithmetic sequence. So, our assignment that will be checked tomorrow is find the following nth terms in an arithmetic sequence with 25 as the first term and 3 as the common difference. So the first term and the common difference are already given. So you are now going to substitute, to use the formula and substitute the following values. And you are going to find the third and the fifth term. Okay? Yes, please answer it on your notebooks. Show your solutions and we will check it tomorrow before our class starts. Alright, is this clear? Is the assignment clear? Alright. Okay. Now, is there any questions with regards to our topic discussed today? Questions? You can ask any questions with regards to our lesson today. None? None so far? Okay. If there is none, I would like to leave a quotation by Eric Hofer that says, "The hardest arithmetic to master is that which enables us to count our blessings." So, that would be all for today. I hope you learned knowledge and skills. Okay, that would be all today. See you again next meeting. Class is dismissed.